All right, guys, today we are going to talk about the mole. The mole is probably one of the hardest concepts in chemistry to grasp just because it's so abstract. So today we'll use some concrete examples to help you understand exactly what a mole is. When we talk about a mole is just a number. It's important to remember that's all it represents, but the specific number that it represents is 6.02 times 10 to the 23rd. This is such an astronomically large number, it is hard to wrap our heads around. So what I'd like to do is start by taking this number and putting it into standard notation. When you see the exponent of 23, what that means is that you are going to need to move the decimal 23 places. Since it's a positive exponent, we're going to move it 23 places to the right. So 602, and when you're finished, you should have 21 zeros on the end of your answer. That number is absolutely huge. And because that number is so big, it is not really a useful number that we encounter in our everyday lives. You would never have 6.02 times 10 to the 23rd pennies. In fact, if I tried to count this high, and I started the moment I was born and I counted as fast as I could without ever stopping to eat or sleep, I would not be able to count that high by the time that I died at the age of 100. So that number is so huge that it is not really helpful when we're talking about everyday objects. But when we're talking about things that are incredibly teeny tiny, like atoms, this number becomes a useful number. So in chemistry, we will often use moles when we're talking about the number of atoms or the number of molecules. All right, just to go back to that idea of what a mole means. If I say a dozen, you know that I have 12. It does not matter what the object is. I could have 12 eggs or I could have 12 donuts. A dozen just simply means that I have 12 of them. If I have a pair of something, that means I have two. So I know that I have two, whether it's earrings or whether it's socks. As far as moles are concerned, moles mean that I have 6.02 times 10 to the 23rd of that object. So a mole is a huge number that you have not encountered in your everyday lives, but it is going to be really important when we're dealing with small things like atoms and molecules. All right, so here you can see I have a visual. I have two beakers, and in one beaker, right here, I have a mole of sugar. Here, I have a mole of copper. Notice that they are drastically different in the volume or amount of space they take up. And if I were to put those on a balance, I would see they have drastically different masses as well. Here's the reason why. Imagine a single copper atom. A single copper atom might look like this. If I have a sugar molecule is much larger. So in these two beakers, I have equal numbers of particles. Let's think about bowling balls and ping pong balls. If I had 12 ping pong balls and 12 bowling balls, I have an equal number of them, but I would not expect them to take up the same amount of space or have the same amount of mass. It's much like that with the atoms. Here, copper is like my ping pong ball. It's teeny tiny. My sugar is more like my bowling ball. It's a lot larger with a lot more mass. So if I have an equal number of both particles, like I do in this beaker, in these beakers, notice that the sugar is going to take up a whole lot more space and it's going to weigh a lot more. So we cannot say that, oh, just because we have 12 grams of something, we have an equal number of particles in each. The size of the particle is going to make a difference. Let's do a couple of conversions, and we can do these conversions with common everyday objects that you're a little bit more familiar with. Then, once we understand that, we can apply that to the mole and to atoms and to molecules. All right, so in my first example, I have 1.46 times 10 to the 24th pieces of paper. Now, first of all, that is a nonsensical amount because that number is so huge, there haven't been that many pieces of paper created since the beginning of time. So I want to take that number of paper pieces and change it into moles. It is no different than saying, okay, if I have 2 dozen of something, I'm going to take that same exact amount, but I'm going to convert it into the number of pieces that I have. So 2 dozen would be the same as 24 of the object. I'm going to do the same thing in this case, except since the number is so large, rather than dozens, I'm going to use moles. So when I am setting up dimensional analysis, which is our universal language in chemistry, and we have to use it for every problem, we are going to identify where we are starting and where we are going. I'm starting with the unit of paper, and I'm trying to get to moles. So in order to go from paper to moles, we need to find the relationship between them. In order to go from paper to moles, I know that 1 mole of anything, any object at all, including paper, is equivalent to 6.02 times 10 to the 23rd pieces. Now that I know my equal values, I'm ready to begin the problem. And when I begin the problem, I'm going to start with the number that is given. I have 1.46 times 10 to the 24th pieces of paper. You are always going to multiply with your dimensional analysis, and the top and the bottom half of the fraction have to be equal values but different units. Since these are equal values but different units, I am going to put 1 on the top and 1 on the bottom. 6.02 times 10 to the 23rd pieces of paper are going to go on the bottom and 1 mole on the top. I knew that because I needed my units of paper to cancel out. Now guys, if you're not understanding the setup here, please go back and watch my video on dimensional analysis, and I'll explain this setup prior to introducing the moles. It might be helpful to watch that video first. Now, the only unit that's remaining is moles, and that's what the problem asked me for. So I am going to now solve. I'm going to solve by multiplying across the top, then multiplying across the bottom. I'm going to take my top divided by my bottom, and when I do that, I get 2.43 moles. This may seem tedious, but at the end of the day, this is going to make our lives a whole lot easier in chemistry. Here's why. I can use this number right here, which is an exponent and a massively huge number that's a pain to do math with, or I can express the exact same amount in the unit of moles, and now I have a much more easily usable number. So it's much easier to use 2.43 to talk about the amount of paper that I have, rather than 1.46 times 10 to the 24th. But once again, these two amounts are exactly the same amount. In our next example, we're going to talk about pennies. So I know that I have 1.32 moles. That's an enormous amount, but I want to know exactly how many pennies that is. So I can set up a dimensional analysis problem once again to convert my moles into pennies. So I'm going to find my starting unit, moles, and find my ending unit, what I'm trying to get, pennies. And I am going to find the connection between them. In order to convert moles into pennies, I know that 1 mole of any object, I don't care what it is, 1 mole is always equal to 6.02 times 10 to the 23rd of that object. In this case, the object is pennies. Now that I've found my connection, I'm ready to set up the problem. And when I set up the problem, I'm going to start with the number that is given, 1.32 moles. I'm going to multiply. The top and the bottom have to be equivalent amounts, which these are. So I'm going to put 1 on the top and 1 on the bottom. The way I'm going to decide what goes where is by making sure that my units match. So a unit in the numerator and a unit in the denominator will cancel out. That is equal to 6.02 times 10 to the 23rd pennies. Now, the only unit that's remaining is pennies, and that's what the problem asked me for. So I'm ready to solve. In order to solve this, I'm going to multiply across the top, and when I do, I get 7.95 times 10 to the 23rd. When I multiply across the bottom, I get 1, divide my top by my bottom, and I get 7.95 times 10 to the 23rd. Remember to always put a unit on your final answer, and this is pennies. This number of pennies and this number of moles are the exact same amount, just expressed in 2 different ways. So now, let's see if we can use this, now that we have a better idea of what a mole is, let's see if we can apply this to an atom or a molecule. All right, so now we're ready to look at an example in which we are talking about atoms. When we're talking about atoms, we are going to approach it the same way. Again, a mole means 6.02 times 10 to the 23rd, regardless of whether we have paper, whether we have pennies, or whether we have atoms. So in this case, we're going to find our starting unit, just like before, moles. And then I am going to find my ending unit, atoms. In order to find the connection between moles and atoms, I know that 1 mole of any object is equal to 6.02 times 10 to the 23rd of them. And in this case, my object is an atom of copper. So now I'm ready to begin my problem. We're going to start with the number that's given in the problem, 1.20, and we're going to make sure to write the unit. By writing the unit, that's going to help me know what goes where in the next step. The top and the bottom of my fractions have to be equal to one another. So these values right here are equal amounts. I'm going to choose to put 1 mole on the bottom and 6.02 times 10 to the 23rd atoms on the top. The moles then cancel out with the moles. The only unit remaining is atoms, which is what the problem asked me for. So now I'm ready to multiply. I'm going to multiply everything on the top together, and when I do that, I get 7.22 times 10 to the 23rd. I'm going to multiply everything on the bottom together, and when I do that, I get 1. Divide my top by my bottom, and that is going to give me 7.22 times 10 to the 23rd. The only unit left is atoms, and specifically atoms of copper. This number of atoms of copper and this number of moles are exactly the same amount of copper. It's just 2 different ways of expressing it. So, as a recap, it's important to remember that a mole is just a number. A dozen means 12, a pair means 2, a mole means 6.02 times 10 to the 23rd. We can use that mole in order to determine how many of an object we have. The object that we're going to use in chemistry are atoms and molecules, since they're so small that a mole is a usable quantity. I hope that helped clear up the concept of a mole. If you would like to see mole to gram conversions, please check out my next video in which we'll show the relationship between mole